In this video, we solve a complete signals and systems problem on the convolution of two discrete time signals. As you can see in this problem, we are given Vn and Wn, and we are asked to find the convolution of these two signals, which is equal to Qn. To solve this problem, we first sketch the signal Vn. To do that, we begin by sketching Un. Recall that Un is equal to 1 for non-negative values of n, and it is equal to 0 for negative values of n. Therefore, this is the graph of Un. Now, let's sketch Un minus 6. The signal has exactly the same shape as Un, but it is shifted 6 samples to the right. In other words, it remains 0 up to n equals 5, becomes 1 at n equals 6, and stay equal to 1 for all larger values of n. Now we subtract these two signals to obtain Vn. Let's draw Vn. For values of n less than 0, both signals are 0, so their difference is also 0. From n equals 0 up to n equals 5, Un is equal to 1, while Un minus 6 is equal to 0. Therefore, the difference is 1. For n greater than or equal to 6, both signals are equal to 1, so their difference becomes 0 again. As a result, Vn is equal to 1 from n equals 0 through n equals 5, and 0 everywhere else. Now we are asked to compute the convolution of Vn and Wn. Before continuing, let's review two important convolution properties. The convolution of any signal with delta n is simply the signal itself. Also, the convolution of any signal with a shifted impulse produces the same signal shifted by the same amount. Using these properties, we can write Qn as follows. The convolution of Vn with delta n is simply Vn. The convolution of Vn with 2 times delta n minus 2 is equal to 2Vn minus 2. The convolution of Vn with delta n minus 4 is equal to Vn minus 4. Therefore, we only need to determine Vn, 2Vn minus 2, and Vn minus 4, and then add them together. We already have Vn. Now let's sketch 2Vn minus 2. The signal has exactly the same shape as Vn, but it is shifted to sample to the right, and its amplitude is multiplied by 2. Therefore, it starts at n equals 2, ends at n equals 7, and its amplitude is equal to 2. Next, let's sketch Vn minus 4. Again, it has the same shape as Vn, but this time it is shifted 4 samples to the right. So it starts at n equals 4, ends at n equals 9, and its amplitude remains equal to 1. Now we simply add these 3 signals together to obtain Qn. For all values before n equals 0, all 3 signals are 0. Therefore, the result is 0. At n equals 0, only Vn is equal to 1. So the result is 1. At n equals 1, the result is again 1. At n equals 2, Vn is 1, 2 Vn minus 2 is 2, and the third signal is 0. Therefore, the result is 3. At n equals 3, the result is also 3. At n equals 4, the 3 signals are 1, 2, and 1. Therefore, the result is 4. At n equals 5, the result is also 4. At n equals 6, the first signal is 0, the second signal is 2, and the third signal is 1. Therefore, the result is 3. At n equals 7, the result is again 3. At n equals 8, only the third signal is equal to 1. Therefore, the result is 1. At n equals 9, the result is also 1. For all remaining values of n, every signal is equal to 0. Therefore, the convolution result is 0. This completes the solution. As you can see, by using two basic convolution properties and carefully sketching the signals, we were able to compute the convolution without performing the summation directly. If you found this tutorial helpful, please like the video, subscribe to the channel, and turn on the notification bell. We have many more solved examples on LTI systems, discrete time signals, continuous time signals, and convolution in signals and system.